Hi guys. So, thanks so much for the awesome talk. I got my power back an hour ago, so hey! I I'm very honored to be giving my first technical talk in Nova Scotia. This was before in Dubai. I used to give like to auditoriums of developers and stuff, and this is the first time I give a technical talk in Nova Scotia, and I'm really, really, really happy. So, thank you for that. Speaking of being happy, my name is Rima, and I am the founder of Begin.ai. And what we do essentially is personalization. And the reason why we're doing personalization is because I feel like every application has the need and the opportunity to deliver, let's call it digital happiness, because we can't, deliver the full spectrum happiness through AI, but let's say digital happiness. Today, when I was coming here, I opened Uber. It didn't ask me, you want to go by horse or where are you going, or it just said, hey, where are you going? I'll fix you up. And Uber Eats is even worse. It just says, hey, are you hungry? I'm like, how did you know? So, and then it tells you like what food you might like to eat, right? So it's pretty cool, and it almost, tricks me every time. Like, yeah, I'm hungry. I want to click this, right? And Netflix, Amazon, Facebook, all these guys. Netflix, 75% of their revenue comes from recommendation systems. That's a huge number, right? 75%. So they're a big company because they have a recommender system. And same thing with TikTok. TikTok is technically a recommender system. That's all TikTok is, right? They're like a huge recommender system. And Facebook got sued a whole bunch of times just because of how good the recommender system is. And Amazon's 35% of their revenue is recommender system. And if you guys game, the best gaming companies in the world have the best recommender systems. But it also feels like your girlfriend is cheating on you. It's like, because they kind of like, they're really nice to you, but because they steal your data, right? So it's like, so how do they do all this, right? So if you come to it, like you're, as a company that goes beyond seed stage, so, you have 5 million users and you're like, okay, cool. Now I have 5 million users. I have 5 million, a lot of books or something, or education, or whatever your company does, really. You're at a situation where you gotta optimize your experience to keep your users engaged, or you're gonna lose them. And I've experienced this personally with my first startup, and it was a freelance marketplace. Because when we were really small, it was really easy. We just said, like, put a job, you find a job, it was an easy match. But when we had a lot of jobs, a lot of freelancers, we had to get smarter about it. But it's so freaking hard to build recommender systems. They're so expensive. Privacy is a huge problem. But if you, close your ears and you're like, I'm not gonna listen to the crowd, I don't care, I'm not gonna listen. And then you're like, I'm gonna try to build this. The biggest challenge is actually the high velocity and high volumes of data. It's so hard to manage events that are coming at such frequency and make sense of them. Because think of it, you gotta load like a massive data set of like what users liked, what users disliked, what did they click, what did they view? Did they go the whole restaurant menu? Did they just see one item and they swap back? All of these events are generated at a high velocity. And you're talking about like billions of events if you have 5 million users. And try to load billions of data points in your Jupyter notebook. Can you? No, your laptop will crash, right? You go to Databricks, and then your boss calls you and you're like, why am I paying hundreds of thousands of dollars for, did you do something in this project? No, we're still POCing. Holy shit, shut down that project, right? So you see where that cycle is going. And then let alone, the math and all that stuff. So I thought there was an opportunity there, and we tried to rethink the process. So what I want to show you today is like how we rethought the process of personalization, and what we brought into the mix, and how we tried to rebuild the recommendation system infrastructure. So step one, we said, can privacy be profitable? Funny thing is, Google proved it can be, yet Google doesn't use it. So it's like, yeah. Anyway, so Google invented this technique called federated learning. Turned out federated learning on its own is a promising idea, but it's not a good enough idea to build what we want to build. So we came up with a technique which is allows us to process data on the edge, on devices, and generate basic, simple embeddings of the data, and then send it to central storage for processing. And that turned out to be an extremely profitable solution from a time management perspective and from a storage management perspective, because I'm not storing everything about the person, every event that happened. I'm just storing the meaning of these things. And once I've done that, we then looked at like possible ways to store this information, and we figured out like knowledge graphs are the best way to go about it. And then, we brought a bunch of techniques like what I just described is a form of differential privacy. So like when we process, we eliminate a lot of information about the user. Feel free in the Q&A to ask me about like the privacy techniques, but I'm not going to focus a lot on them. But essentially what we did is, like I said, as the user does a lot of interactions, we have an SDK. So we have an Android SDK, an iOS SDK, a Python SDK, JavaScript SDK. And you might ask, why Python SDK if we're saying edge? But you can also, we can't be blind to the fact that people have had stored a lot of information already. So we want to allow you to do distributed processing anyway. So you can process the data that you have in a server and the data that's on a device and whatever, and generate the embeddings from it. So our SDKs, given a description of the data, will generate the embedding and send it for learning. And then actually, I'm going to mention, since you're all data scientists, once the training is done, we can our SDKs also support inference on the edge. So you don't necessarily have to do high volume server requests to do inference, to say like, can you tell me what should be the next movie I show to the customer? You can ask that question on the edge without going to the server. And that saves latency. So basically, this is how our database looks like. Brilliant, eh? So, so this is a node, which is the blue dot right there is a person, and then the circles around them is the books they interact with. And I don't know if it's visible, but the edges of the interaction are a sentiment. So they say like, the blue interacted positively with that dot, interacted negatively with this dot, and it gives us a summary of the interaction. We don't actually really need to know what the interaction is. We just need to know the meaning of the interaction. And the highlighted dot there, this is what you see, and this is what we see for them. And what these are embeddings, essentially. And we see the first thing we get is the first generated embedding of the user. Actually, I have that in the demo. It might be better to switch to my laptop, if that's okay, in a second. So this is a book. What you can see is we have an ID, which might as well be the wind speed in Halihax. We don't really know what that ID means. And then you see like different versions of the embedding. So like the embedding row means the first version of embedding we received, based on, it has like a number 34, which tells us based on what schema this was generated. And then you see stuff like embedding normalized. So this was normalized for a certain objective. And then if you look at, if I look at the person, you see like we have a lot of stuff about this person, but if you go to the row embedding, actually it's empty, because this customer didn't tell us anything about the user. So we generated embeddings based on the position of this user in their context, in their universe. So they're like, based on one of the neural networks we train, it's called IOU. It's an IOU-based network, so intersection over union. So what it does is tries to generate an embedding for this person that positions them closer to the things they like and further away from the things they dislike. And that makes the embedding of this person really smart, and all we have to do is a cosine similarity to say, hey, show me all the books this person is going to like, essentially. And in practice, so what we, I'm just gonna go down here so you can see. What we do is like, you go and you just like describe your data schema. So I'm just gonna take one like here. This data schema essentially is what the user has to tell us. So they give us like, so what they know about the book, they say like, we know their average rating, which is a number between 0 and 10, average author rating. And as you can see, it's not the data, it's just a description of what the data points might be. Publication month, it's a categorical thing. And we process text data as well, so you can tell us like, and text processing will be like BERT tokenization thing. And then it tells what the interactions are. So you say like, if they read the book, that's neutral. If they love the book, that's super positive, etc. And if you don't tell us anything about the user, then we're just gonna position them based on their interactions. And so once this is done, all you have to do is like, copy all this integration code, and then each SDK ends with learn from data, which is essentially the part where the SDK downloads instructions from our servers and then processes them and applies them on the data locally. And then once that's done, like basically the user would go and just enable an algorithm. So we have a bunch of algorithms, like recommendation one. And then like an hour later, they get their performance metric. And it's crazy because, so I said, can privacy be profitable? The craziest thing is like this data set, 720,000 users was training in like 30 minutes. If you do have, including all cycles of all processing, of like generating the embeddings, optimizing them, yada, 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 on a laptop, which is crazy compared to like how much effort it would take in a production setting differently. We're very proud of this efforts because it's now patent pending because it took a lot of work to figure it out, and then we make it available, make the recommendations available through like the same SDK. Begin recommend, you give it the project ID and it goes. And then if you run it, you just get which books and their similarities. That's it. I mean, and the same technique, we were able to generate a lot of different things. Like we're able to do classifications. Because if you think about it, you always generate the embeddings and then you do your machine learning. If we reinvented the method of generating embeddings in an efficient way, you can do a lot with it, right? So we're able to do even analytics such as churn prediction, or like identifying which customers are reducing in usage or increasing in usage in a very simple way with much simpler algorithms than you would usually have to do based on like high voluminous data. What this allowed us to do as well is to run like a lot of experimentation because we made it available through the interface where you can say like experiment with this data set separately from this data set, and we were able to learn a lot from the experimentation process. So I guess the biggest learning for us was that I started with federated learning, which is extremely complex. So federated learning, it happened during COVID. I was stuck in my home office in Halihax, and I was thinking like, what can I do with this time? I can't go anywhere. So I just figured, let me do some research. And I was working with researchers from Oxford on this federated learning stuff, which is now used by the Facebook PyTorch. But the problem with federated learning is that we had to literally rewrite the description of every tensor to make it possible to manipulate remotely. So it was extremely complex to work with, to solve the simplest problems. And the key, like I can tell you, the key issues with federated learning. So what federated learning is that you take the model and you send it to the edge, and then you take it to another, you bring it back, so you bring back the model weights essentially, and then you send it to another device, and then And then you get all the model weights and you average them in a particular way. So the problem with that is you have to have balanced data on all edge devices, or otherwise you're going to have a skewed model because you've never seen the data, you don't really know what's going to happen. And the other problem with that is that if you try to apply it on simple user applications where you don't actually have voluminous data on edge devices, like for example, recommender systems, the user, yes, is a single user is doing a lot of interactions, but sum them all up, they're not enough to train a model by themselves. They don't generate enough meaning. So that was the motivation to look for a different technique of process on device and train centrally. And that's pretty much it. So thank you very much.